So we'll just explain you quickly the structure of this artist talk that we'll have here and make a small introduction quickly. Then Inge Herrmann will do a presentation about her research in women's health, which is the source of the artwork you see here, the labor artwork. Then we'll engage in a conversation together. And I think at the end you will even have the chance to have a hand-on or a manual or a physical empiric experience of how the artwork actually functions, and we'll have the 3 last pieces produced. I'll start with a small intro of our guests at the panel today. First, myself. I'm Adrian Notz, curator. I used to work at the ETH in the AI Center and was able to try and bring, or was able to have the chance to try and bring artists and scientists together in different collaborations. And the collaboration between Liat and Inge is maybe the most fruitful one because it is based on chance and first total misunderstanding or non-understanding of each other. I put them on a panel together and they didn't know why they're talking together. But now, 3 years later, they're still talking together and still collaborating. So randomness or chance as a good creative tool is something I learned from my time with Dada. I used to be director of the Cabaret Voltaire in Zurich. So I'll start with, I guess, I don't know if I have to introduce Liat again, but because she's been introduced a couple of times. Shall I introduce her? Yes? Okay, for Anne, for the new arrivals. Liat is a media artist. She's based here in Berlin, and she's exploring how painting can be redefined in the technology-driven era. Since 2016, she has been collaborating with the University of Konstanz, who's a co-organizer of this symposium today, on the development of the E-David painting robot, focusing on integrating robotics and computational processes into creative image making. Currently, as you all know, that's why you are here, she is the artistic director and artistic researcher for the EACVA, the Embodied Agents in Contemporary Visual Art project. So this here is a symposium of this project, as you might know. Grayver also holds a master's degree from the HGB in Leipzig, which signifies her as a real painter, so she knows how to paint. German style, of course. She also studied at the Accademia di Belle Arti in Naples and at the New York Art Students League. Her work has been exhibited internationally in numerous solo and group exhibitions, and Liat is a member of the Saloon Berlin, a network for women in the art scene, and an associate artist researcher in the epistemologies of aesthetics practices program of the ZHDK, which is the Zurich University of Arts, and the ETH in Zurich. Our second artist and researcher is Daniel Berio, who you also might know from the Goldsmiths University. He is a lecturer at the computing department in Goldsmiths, University of London. He's also a computational artist and does research at the intersection between computer graphics, robotics, and graffiti art. So that's his artistic background, graffiti art, which is also proving him to be a real artist. He completed his PhD in computing at Goldsmiths, where he researched methods for the computer-aided design and procedural generation of synthetic graffiti art and calligraphy. Previously, Daniel specialized in multimedia software development, especially applications involving real-time hardware, accelerated rendering, and vector graphics techniques. Artistically, Daniel comes from a graffiti writing background, and he explores the same aesthetic in algorithmically generated forms. And last but not least will be our first speaker today is Professor Dr. Inge Herrmann at the ETH Zurich. She's an engineer and is a professor of medical technology innovation at the University of Zurich, the Balgrist University Hospital, and the Swiss Federal Labs. Her lab, which I always like to quote, because it has such a cool name, is a Nanoparticle System Engineering Lab, focuses on developing the tools and technologies shaping the future of medicine. These innovations advance diagnostics and therapy, translating into clinical applications and successful ventures. Her achievement includes the Eccellenza Professorial Award, Latsis Prize, the Global Women's Impact Award, and Largiader Award. Maybe just to explain how they work together, we have Daniel, who was basically we have like the scientist, the researcher, which is Inge, working on, she will explain later, on 3 different projects in the realm of women's health. Then we have Liat as the artistic, and as Daniel also said, she makes the whole conceptual arch of the work. And Daniel likes to call himself just like the technical guy who knows how the stuff is done. So we'll have this kind of role play tonight. I kind of work as a curator and here tonight as a moderator. And with this, I would like to hand over to Inge.
All right. Oh, perfect. Thank you very much, Adrian, for the introduction, and it's a pleasure to be here. As you all heard, I'm a scientist, so I really have no art skills whatsoever. But I'd like to also clarify that when we first started to collaborate with Liat, I think, at least for me, it was pretty clear that it was something cool. It was more the other people that were like greatly disturbed by us interacting, and they were like, yeah, how can, like, what are the commonalities and whatnot? I think personally that there are a lot of commonalities, like we both work with robots, we both like technical things, and I think we're both really inspired by the intersection of art and science. So Adrian has introduced already a bit the concept of my lab. We try to really merge different disciplines, of course, mostly different disciplines in natural sciences and engineering, but of course we also try to include like really a diversity of other fields, and that's why like this intersection with art is so fascinating to me personally. And so a growing focus of my lab is actually women's health, mostly because it's a very under-researched, under-explored, underfunded, and under-discussed area in science and technology. And as a result, there are still very big and very under-addressed needs and clinical problems in women's health. And so one of these problems I think most of us are now familiar with is endometriosis, which is a very, very painful disease that affects 10% or even more, mostly young women. And they experience excruciating pain, especially during menstruation, and it's often not really accepted and recognized, not even by doctors, which makes it extremely challenging, both physically but also psychologically. And then there are a lot of other topics in women's health, which are basically, viewed very critically or not even discussed by society, including menstruation, which is basically a subject that's not really talked about, not even today. And there are also a lot of things that are unclear in terms of how a female body even functions, because most clinical studies were basically run on male subjects. And so there are just a lot of fundamental things that are unclear. Including, like the development of a fetus, the development of a placenta, what it means for later in life, and so on. And so I'm just going to briefly introduce one project on endometriosis research where a couple of years ago we hired in my lab a gynecologist. So that was also an unconventional combination of engineers and chemists with a gynecologist. And he brought this clinical need to us that's basically that there are no good non-hormonal contraception solutions that serve a large population of women that don't want to undergo permanent sterilization. And so as a result of that, together with him, we developed a small polymeric implant that's basically a jelly or a gummy bear, but in a different shape, that can be implanted in the fallopian tube and can occlude that tube, so sperms cannot fertilize the egg, but this occlusion is reversible. And so it's very, very gentle, it doesn't harm tissue, and this jelly can be removed whenever wanted, just by the application of light. And so with this, we can offer a very gentle, non-invasive, non-hormonal way of contraception. But what's maybe more exciting is that this implant that's placed here, can also potentially prevent the backflow of menstruation blood, which is still believed to be the main cause and driver of endometriosis. And so with this tiny polymer implant that we can put in the fallopian tubes, we can potentially offer mechanical non-hormonal contraception and also mechanical non-hormonal prevention of the progression of endometriosis. So this implant can be removed by light, and it can be placed in a very minimally invasive way, not even requiring general anesthesia. The implant is implanted with a small catheter, and it swells once it comes in contact with fluid that's contained in a tube, and then it can be removed by the application of light whenever the patient or the women are interested in getting pregnant. The tube occludes the fallopian tube and blocks the passage of endometrial cells, as shown here on the right, and it also occludes the passage of sperms. So this is a project that's currently in the phase of preclinical translation, and because patients are really interested in getting access to this technology, we're at the moment finding investors that actually support the preclinical development and the studies to show that this implant is safe and is safe in the long term, especially also for these young women. These discussions with this gynecologists also drag the focus to other areas, and as I pointed out, menstruation is still a taboo to some extent. And we thought that maybe we can also do something interesting there and use menstruation blood that's generally considered as a waste and still be perceived by society as something disgusting. And I cite a quote here, some reviewers or some people that actually have discussed this technology with us. We think it's completely untrue. We think it's a great source and a great value where we can access health information in a non-invasive way. And I'm sure that many of you actually went to the doctor and the doctor drew blood and it was annoying because there was a needle. We think a menstruation blood can give access to blood in a needle-free way, of course in a subpopulation of menstruating women, but these are still 1.4 billion people around the globe. And so basically what we do in this technology, we detect markers of cancer, infection, potentially endometriosis, fertility, in a way that basically functions just as the COVID test. But instead of detecting COVID, we discuss these other diseases, we detect these other diseases, and instead of saliva, we use blood. And you can imagine, just like the COVID test, you have this lateral flow assay that gives you a line. You use your smartphone, in this case, to quantify what the line tells you, and then you can extract concentration of biomarkers. And this can be integrated in an app that helps you with the readout and the interpretation of that sensor that's actually integrated in the menstruation pad. And so there's no huge user interaction needed, so you don't need to process, you just need to take a photo of that assay. And we think that this is it's not a diagnostic, but it's a sort of tool that warns you that maybe something should be checked and followed up by the doctor. And the last project I'd like to quickly show here is this project where we looked at basically the origins of life a little bit, in a sense that we looked at the human placenta, which is a very fascinating organ because it's a temporary organ, and we can actually get this organ freshly from the clinic, and and analyze it and try to understand what information is contained in this placenta and what it can potentially tell us about the mother, but also the offspring. And so we looked, and it's a very busy graph, but we looked at basically the information that's contained in placental tissue by different methods, one of them being the analysis of metals and minerals contained in that tissue. We see, for example, that if women are exposed to heavy metals, that they tend to have more inflammation in the placental tissue and also more mineral deposits. And these are factors that are also believed to be causative of pathologies, including preeclampsia, disease of pregnancy, and potentially also endometriosis. And we can also see that these placentas are very variable across different women. And they also show a very variable degree of calcification or mineralization. Mineralization, we mostly think of cardiovascular calcification, but we also see these calcifications in placentas, and we see that some people have a very mineralized placenta and others have almost no mineral, but we still don't understand what this really means in terms of the future of the mother. Does it mean she has an increased risk of cardiovascular calcification or not? So there are all these questions that are still open. And then we can also look at these mineral structures. That's actually what this project is mostly about. We can look at them under the electron microscope at very, very high magnification. And we can see like how these structures look and what they're composed of. And we find these structures not only in a maternal part of the placenta, but also on the fetal part, even in the umbilical cord. And this is a tissue that only exists for like 9 months. Even this tissue, the super young tissue, can mineralize. And so we're trying to understand what this means and if we can deduce any kind of information for later in life. And with this, I'd like to just come to a short summary. Unfortunately, women's health is still hugely under-researched, underfunded, and under-discussed. And this actually leads to huge suffering of the patients, even nowadays with modern medicine. Most of the conditions are inadequately addressed, and many doctors still don't believe that pain is real, which is very problematic. But for us as researchers, this is also, of course, interesting because even small steps, our baby steps, can change a lot, potentially, for these patients. And with everything, I'm a big believer in interdisciplinarity. Like, it starts, of course, in the sciences, but it extends to artists, and of course, also like all the stakeholders, patients, insurance companies. So we really think that this collaboration can advance technology and also treatments. And with this, I'd like to thank you for your interest and for listening.
Thank you very much, Inge. I would like to ask Liat and Daniel to come in front for our conversation. And maybe we can continue a bit with your research, Inge, to also understand a bit better what we are looking at here. Daniel pointed it out, which image is being recreated at the moment. I don't know if you will realize which one it is, but maybe later on. Maybe one first question is like, how did you get the idea of doing this research on the placenta? I think you didn't mention it. Was it also in collaboration with this gynecologist, or?
So basically, I was always very fascinated by mineralization in tissue. It's also something that we can analyze with material science technologies very well, because these structures have very good chemical signatures and also very good contrast under electron microscopes. And before working on the placenta, I worked in cardiovascular research, and I looked at what mineralizations form in heart valves and artificial heart valves. And then when we got access to these placentas, of course I was interested to see if we could get any kind of correlation between the mineral that exists in the placenta and minerals that form in these patients later in life. Of course, this is research that basically has a time horizon of 20 years or more, so you need to be really patient. And also we need to follow up these women that actually gave birth, like we need to follow them up like 30, 40 years later, where they are potential candidates for cardiovascular mineralization. But of course, what I find fascinating is that there's so little known. Like we know basically nothing about the placenta. And that's what got me started.
So the research is actually about predictions for two humans in that sense, for the one who produced it and the one who used it in that sense. You mentioned the interdisciplinary approach to your research, and I'm always curious in like how fascinated you are about this collaboration with Liat and with Daniel, but also in other projects with Liat. And I wonder what's the point for you? I mean, what does it, besides having a communication tool, does it also inspire you in your research, or does it, give different perspectives? Why do you do this? It's certainly not easy.
It's fun. I think maybe not easy, but it's fun. I think it's always good to have different perspectives. And to be honest, I'm really bored by my peers and my colleagues because they were all trained in a way I was trained, and we all think alike. And when we see something, we see the same thing, and we ask the same questions, and we follow the same route. And I think if we interact with people from other fields, and Liat is really special in this because she's also super deeply interested in the science behind. It just adds so much perspective to our science, and it gives us inspirations, and it actually makes us reflect on things maybe we wouldn't without having her in our lab.
You mentioned that you work with robots like Liat does, and when I approached you first, you're also part of the AI Center, so you also use AI in your research. And when we tried to find a common ground between you and Liat, I thought it could be painting on different scales, because you're kind of using different pigments also. That was a former project with Liat to, let's say, paint nanoparticles that can then identify infections or diseases and so on. But maybe you can explain us how do you use robots and how do you use artificial intelligence?
Yes, so we use robots as surgeons, and it's very slow, I can tell you, because it takes us so much time to train them, even what a surgeon can do. Of course, we try to train them so they can do better than a human surgeon. But indeed, there are a lot of commonalities, and we try now to use robots to print inside the body. So, for example, you can imagine if you lose part of your meniscus or of your cartilage, usually doctors need to make a big cut to repair that defect, and of course, this is very annoying for the patients because they have long times of recovery. And so what we're trying to do with robots at the moment is we're trying to print these tissues inside the body, but with just a tiny, tiny incision. So basically, it's an endoscopic kind of device that only hurts a tiny, tiny bit of tissue, and then creates this material that repairs the cartilage or the meniscus. It creates that material inside. So basically, we don't want to create a lot of tissue damage and still print and create large materials on the inside of these patients.
Okay, thank you. And AI?
Yes, I mean, AI is everywhere. I mean, first it basically is a big part in the control of the robots. So when they actually become aware of the surrounding, and as you can imagine, to navigate and to be aware of the surrounding in the human body is maybe even more difficult than outside. And their AI is everywhere. I cannot think a single project that doesn't have AI in there somehow.
In one of the first lab visits I did at your place, it was also that you use it, for example, to not measure the temperature, but to understand temperature in a three-dimensional way, because you use laser for stitching wounds within the body. So it's in a way almost like a pattern recognition on a temperature scale, so to say. I would like to move now to Daniel, and I was told by Liat that I'm not allowed to call him only technician or only technologist, but because this whole work, labor, is based a lot on human labor and on manual labor and on mental labor. Also on a book which I just read by Matteo Paschinelli, his, how's it called, The Eye of the Master. So in a way, calling him a technologist can also be, or just a technician, can actually be a big compliment, because he has a lot of manual knowledge in producing this artwork. And he also just told me that some of the problems they were having while developing it is also because Daniel is also writing a paper at the same time while you are producing the artwork. You know? So there's a direct translation from very physical, manual, technical labor into theoretical research paper, and then again back. So what I wanted to know a bit, and I still haven't really understood how this whole process works. So we have a microscopic or actually even nanoscopic image of one of the placenta cells. We see here placenta cells. You take this basically, I don't know, JPEG or TIFF image, and then you translate it from that image to the robot. And I know there's a couple of steps involved using AI, and so maybe you can give us a small kind of sneak preview into this kind of division of labor in the process.
Okay, it's very laborious about the coding part and also building it, because it involves operating the robot, which is, it connects to what we were talking about before, because it's a lot of work, right? Robots don't replace us. We're working hard here, controlling the robot, making sure that it does its job, etc. But going back to your question, the procedure goes as follows. We divide the image. Quite simply, we divide the image into tiles. And then each tile is used as a seed for AI-driven generation procedure, which essentially, I'm going to show more videos and details tomorrow, but essentially starting from the image, we start some strokes, some curves that are used to drive the robot, and they start a bit randomly, placed in certain positions. And then there is this optimization that moves those curves in space to reconstruct the intensity of the image, and somehow also the structure, while following a certain type of style. And this is determined by an image input, but also from some ideas of how we move smoothly when we draw, right? So that connects to other research I've been doing. Mm-hmm. And then it's a matter of like running each tile, and it takes, it's not too long, it takes like maybe a couple minutes per tile, something like that. Run a bunch of iterations. There is a image there that shows an earlier process for each tile, but interesting because we're using, I'm using behind the hood this model which is called CLIP, which is the backbone for a lot of the current generative image AI that you see, and it's this model that has a structure internally that connects images to text, right? So essentially what the model does when it sees this part of a placenta, which essentially is like a grayscale blob, it somehow comes up with things. So it's interesting to see how this, I don't really have a control on that much, but it's interesting to see what it kind of ends up giving out as an output. So that can be a surprising element in the procedure, yeah.
Yeah, when I saw that, there's like a small sketch over there on the wall that shows the process in 4 or 5 steps, no, from the grayscale image to some kind of almost calligraphic pattern.
Yeah, so it's like it starts from a soup of curves, and then those curves slowly get transformed into the final result. And yeah, it's like 300 steps. You could do more, you could do less.
Yeah, the last one has 299.
Yeah, because we start from 0 when you
okay. It's a technician.
So 0 counts.
I was when I looked at it, I was wondering about the term of abstraction, for example. Like, is in a way, to be able to create all this, let's just call it algorithms and programs and coding, etc., that is a form of abstraction of dividing the image in one point, but also the labor, etc. But then again, you are doing like a kind of counter abstraction almost. Is it like because you're interpreting, or the AI is interpreting a lot of structure into the grayscale blob?
Yeah.
Is like, what is the, can you work with the term abstraction?
Yeah, like technically, if you were to ask me, like usually like this kind of procedure, you would do it, I don't know, with a portrait, and then it's a good point you're making. Then you would call it abstraction. But in this case, it's almost the inverse. You're right, because it's starting from, you know, what we're trying to do is like create a grid of tiles. Each tile is generated on its own, but at the end of the day, the intensity gives a global structure that you should be able to see. When all of those tiles are done, you should be able to recognize that image, more or less, hopefully. But because each of these blobs is, when you look at it alone, a grayscale blob, indeed it's some form of inverse abstraction, because the AI model is kind of pushing it in a direction that sometimes looks like text and follows kind of this calligraphic input that gives it a bit of structure. And yeah, indeed, yeah, good point. Yeah.
So it's almost like an interpretation, as you said, of the intensity of the image.
Yeah, that's like how those systems work. You have a bunch of cost functions, objectives, and one of them is very crudely an intensity. So give me an image that has those intensity values. Yeah.
Okay, then I would like to move to Liat, and maybe I can give the microphone before we tear out the cable. So the project is called, as you might have seen and read on the curatorial text as well, labor. And we talked about this term, as I mentioned already, in relation to research about the origins of AI and algorithms and algorithmic thinking, division of labor, and so on. But also, so labor in the sense of work, of manual work. But also, because we connected it to Inge's research, also labor as the term of giving birth, the pain that women have before giving birth. So in that sense, we try to combine, just with the word maybe, these two topics in this artwork. And as far as I've experienced, also in collaborating with Liat, the first meaning, the labor meaning of working, is very important also in this artwork, where you try to make this translation again, or maybe an abstraction again, from this digital realm into the human labor, where you actually have to put up the tiles and install them. It sounds kind of absurd or contradictory to talk about human labor while using a robot, using all this AI. But I think that's maybe one of the essences of the research you're doing, trying to, as you said in your work at the Collegium Helveticum, it was about working with the robot in a more intuitive way, which would also in that sense give a new dimension to labor. Can you elaborate on this labor dimension and painting, your relation to the robot in this project?
I think there is a specific term that is missing here, and this is embodied intelligence. That this is something that is embedded in the work of labor craft, I would say. In that case, people who are doing like Handwerklichkeit, like in German, manual working. It's a knowledge that is embedded in our tip of our hands. It's something that as well Daniela Mitterberger talked before in her presentation about the intelligence that we have in our hands, and this is something that Julia talked when she explained the neuromorphic process, like the biological inspired machines that they are building. This is what you try to call about this intuitive. It's a knowledge that is it's different than our intellectual knowledge. It's something that is embedded in us. And it's very important knowledge that was somehow being ignored in our Western society, I would say, since the kind of the intelligent time, like the Enlightenment time, sorry. the Aufklärungszeit, where there was kind of a strong division between the intellect and the body was being suppressed down. And that is something that resonates as well in what Inge is right now researching. This is the female body, the woman health, that is responsible for the creation of life in our society. And I guess a woman here who gave birth in a Western society came across how, I can talk at least from my own private experience, how much we're being pushed not to rely on our bodily knowledge of our instinct, but actually to rely on the machines who are going to tell us, the monitors who are going to tell us what to do and how to feel. And for example, your pain or your bodily knowledge is not important, and you kind of even need to, or require to distance yourself from it. And I'm making a logical jump into the painting, but this is something very similar when we talk about the knowledge that our body has, when we need to operate a very hard to predict material such as paint. A brush has millions of tiny hairs that deform and change during the painting process, but as well with interaction with the material, with the canvas or with the paint. The temperature of the day make it look different. The thickness of the canvas make it look different. And this is something that Danny and I encounter right now, because part of this work, we are not showing a finished work of art. It's not a finished painting. We're showing a performative work of art where temporality became an important element. We are building it day by day, and we wish to be much more far along by today. But
a million of hairs of the brush.
Exactly. There were some issues between our expectation, where the simulated world showed us how it would look like and how it came out. And we realized, oh, we need, like, coincidentally, the gallery had tons of fans here, so we used it to like speed up the drying time. Oh, we don't want too much wet. Let's take one ventilator down. How much time it takes us to do 4 tiles in a row? Oh, it's too much, one dry out. Let's do 3 tiles, so it's going to be half wet. Like those small elements, this is us adjusting to a very deterministic process the machine is doing. And if you will see in our working corner there is a huge pile of unsuccessful tiles that in the beginning we thought they were very successful, and then we were unhappy with them and let's do them again. And this is a knowledge that if I, as a trained painter, I would be able very quickly to adapt myself. But not when you work with a machine. And suddenly there is a huge distance between us, and all needs to go through a code. So you need to think of this intuitive knowledge that we have, and then you need to break it down into a language. How can you put it in language, the behavior of a brush, and this like really super sensitive reaction that we have to this materiality. So one important aspect of this work is to kind of bring back the focus on the importance of embodied intelligence in the time of AI, where we so rely on simulated knowledge that a machine gives to us, and we kind of almost believe as if this is the truth, but suddenly no, our body knows different things. And how can we use computational knowledge and robotics to kind of extend or enhance our ability, but not solely rely on it? And right now we're fairly laboring here in an almost like factory manner on creating those tiles and reevaluating it and then adapting the setups and the code accordingly.
Yeah, and also it's actually more impractical than painting by hand, because painting by hand you're continuously adapting. An error might be a serendipity and your painting takes a new shape, and here it's like, oh, this is not good, let's start over. Or like, wait a minute, I'm gonna recode this. I'm gonna rerun all the so it's a lot of labor, and sometimes, as Liat says, is counterintuitive, right? Very different from painting by hand. Yeah.
You were also, like, at your research you were doing at the ETH, you also worked with the Institute of Neuroinformatics, and they used special processor and spiking neural networks and special sensors, etc. Also, I think Julia also talked about it today. Did this help in terms of shortening the distance between the, noticing a failure and adapting, or aren't you there yet, or is the technology too far away?
I think you're mixing 2 different projects here. Because there's something that Julia said before, one robot is not the other robot, and that was a painting robot and this is a painting robot, but they're not painting the same thing. And with Julia, the project that we work with there with Lioba together as well, was trying to define how can you understand a brushstroke and recreate a brushstroke. So there was not really a place to say, let's try it again, or there was kind of a conversation with the machine to push it into the limit and to just really kind of emphasize how complex a brushstroke is. Because when you think, what a problem, you take a brush, you make a line, here you go. But try to repeat it. No. Do you know the pressure, the velocity, the tilt? Do you know exactly the state of the ink or the paper? Like, there were so many things that are just built on your sensor. And then we used on real-life feedback situation where the robot always needed to adapt to itself. And the technology we're being using it's a very experimental technology that is very sensitive to temperature, and it was very hot, and we need to have ice packs to cool down the processor so it will behave as we want it to. So it's a very different kind of situation. While the robot we are working here right now in the system with Danny, we are not even using visual feedback. It's really based on deterministic processes, like the robot doesn't see what it does. It's more us seeing and then adapting and deciding what needs to be deterministic in this process, but what needs to be human. Where we take the ability, for example, taking those super complex images that are based on patterns from nature, manually try to kind of paint it again in large scale, it's very hard. But there is something that the machine, for example, can do with the stylization of it. We're using a lot of tricks to create a kind of uncanny aesthetic, I would say, by repeating some of the path, the trajectory several times with a bit of offsetting and changing the brush or the color. So you have something that looks very spontaneous, but it's extremely precise, and it's happening in such a large scale. It becomes kind of strange, a very controlled hand on a very thin line that looked like as if it was kind of a Jackson Pollock throwing the paint from afar, but it was actually the tip of a brush, very stable, being go through. So there's a kind of a mastery that will go to kind of calligraphic knowledge. So we're playing with a lot of different kind of aesthetics with the support of computational power and robotic powers to bring this into the kind of front. And I think I'm curious at least to see how it will look as a whole, and if it would feel like something that it's like painterly, or it's graphically, or it's mechanically. And this is one of the things that we struggle quite a lot, because, oh, let's make it look very painterly. Let's put tons of paint and make it like smooshed together and mix. And then, oh, we were so happy. And then we put there, it doesn't make any sense, it doesn't work. Let's make it graphic again. And it looks too robotic now, it's too clean. So this is where we are as well trying to find the boundaries of what we want to do. So I think the technologies on those two projects are very different, but the questions, the artistic questions and the aesthetic, no, they're actually very not similar. They're asking different boundaries. The similarity is only the questioning of this brushstroke.
And the labor.
The labor and the reminiscence, though, of a human hand or a mechanical hand behind it. And yeah, we labored a lot with Lioba.
So basically that would be the, let's say if we take it away from the scientific and technological dimension, the artistic decision is like to say, okay, now it's too abstract, or now it's too graphic, or it's too messy. So it's actually that kind of aesthetic assessment, so to say, that you make together. There's another dimension that you mentioned, which is maybe more a kind of big conceptual framework. And the reason that we have tiles over here, at least as far as I understood it, is that you have the Ishtar gate as a reference, which was built by Nebuchadnezzar, and you mentioned that it's a gate of fertility, so to say. How does this, what kind of role does this gate play besides making tiles?
So this actually goes back to a different project that Danny and I have done called Continuum, where we worked into Arabic geometries, and it's like infinite structure that was being created. So this has kind of pulled me into, I would say like more, like the specific, it was Middle Eastern aesthetics, but it's something that is like patterns, creation in many ancient cultures. It's something that is been shown all over the world. And I found interesting how this is kind of closing a loop with computer-based generative art, as like all the fractal stuff from the 70s and the 80s, like kind of going back into much more ancient social practice of patterns creation. And that kind of pulled me more into like ancient art. And there was a different project I've done with Inge about the Egyptian blue color, so I was already like all immersed in this like different kind of inspiration of visual that was not very contemporary, I have to say. Despite working with contemporary technology and research, my artistic and cultural inspiration were much older. And that's kind of how I got into the Ishtar Gate, and I wanted to do something that is large and having created by many, many like kind of tiles that comes together. And this is how it started, actually with much more blue paintings, and slowly it migrated into the greenish colors from artistic reasons, aesthetical reasons.
Okay, thank you. It's almost like it seems almost like a contradiction, because what you're trying to do over there is also create a three-dimensional space. No? You're working with depth and different structures, whereas, as far as I understand, the patterns of Middle Eastern art is more, or calligraphy in that sense is maybe more two-dimensional. You're not creating spaces. You don't have perspective, no? Or
I mean, I'm not sure about that. Like you can have, if you see some Islamic patterns, for instance, they definitely have, I think, a depth point to them, and maybe you could say they're like 6, 7 dimensional. I don't know.
It's not a point, but yeah. It's not. It has depth. Yeah.
It has space in it. No? Okay, we are already at the end of our 1 hour of conversation over here, but maybe we can still open it up to the audience if there are any questions to our panel over here, to Inge, Daniel, or Liat.
Thanks. Thank you so much. Very interesting project, I cannot really emphasize more how much I agree with Liat, your opening statement that this is about embodied agents, and the fact that there's intelligence is happening not only on the level of, image generation, and the fact that when we're talking about artificial intelligence and the term of general artificial intelligence, or AGI, and it's still happening in this continuum of more digital space, or in the processes of images generation, or conversational models and stuff like that, but not yet on the level of physical interactions. We're kind of diminishing. I feel like we're diminishing human intelligence by only, we're forgetting about physical processes, we're forgetting about craft, and the fact that intelligence is happening on the level of bodies as well, not only on the level of brains. So I just wanted to reinforce that. And the question would be, I understood completely that the project was, and the work with the robot was deterministic. It didn't have a feedback, but in the context of embodied intelligence of the machine, how would you see those processes being implemented? What if you could give the machine more intelligence and autonomy? How would you reimagine this project being done?
I'm just going to get closer to you, Danny. It's kind of interesting because I was like, if I would have needed, or Danny and I would have needed to have visual feedback, we probably would have integrated it into the system, because we have, as part of this project in the University of Konstanz, they have a mechanism of visual feedback working that we could have said, okay, let's try to integrate or borrow it into it. But I think on my side, what I would like maybe to have is sensors for the pressure. To play with that a bit, to say, okay, how can I make a more articulate stroke thing? Something that Danny's put his entire research into those really articulated.
Articulated in the sense of shape, but it would be cool to go further into articulation of the brush, right? Which I haven't touched on.
Yeah,
yet.
and for example, what we have, like a lot of those situations, we want to have a very thin or thick stroke that's happening at once, that are changing its size, but we intentionally making the surface, like the gesso, not equal, and sometimes the robot can take a big lump of paint and let it dry there.
As your daughter did.
For example, my 4-year-old done some of them, so it of course less professionally look like. But then a brush, like a stroke that's supposed to be super thin, suddenly becomes super thick because this extra couple of millimeter, and there is something nice about the organically that what it brings. But I think in terms of ability of data collection and maybe for later project articulation of a machine, this is something I would be happy to have. So censoring of the, because not only the pressure of the brush against the surface, but it's as well like the viscosity of what happened with the state of the paint when it's more dry or more wet, for example, and how that affect. So yeah, I think that will be something to play with.
Yeah, but in this case, we were the visual feedback. so it's like, yeah. Yeah.
It's still a collaboration.
Yeah, absolutely, yeah.
Any other question? Maybe, yeah.
Thank you. I'm curious about the status of the robotic arm. Do you understand the robotic arm as a tool to paint or as the material which also enters, not physically into the project, but yeah, is it part of the material of the whole thing or another paintbrush?
Yes.
I would say both, because it is another paintbrush. It's something that we do use in order to make this painting happen. And one day this work will be hung without the robot beside it, but here we do it in a gallery that the entire front wall is window and we are painting in the space. So we didn't like done fabrication at our studio or the lab and brought it in. So it is important that it stand there as an object, I think, because we are as well playing with the perception of the audience, what it makes with them of seeing a robot work together with two people to make an image, to make a painting. First of all, a robot painting is something that is kind of strange to a lot of people. Then watching it and then making an image of a placenta, which is a kind of strange, all of those connections together. But this is something that we kind of enjoy playing with. It was like just creating this question mark, why this is happening.
Thank you, all three of you. Question more for Professor Hermann. I was wondering, do you see some potential for the understanding that Liat and Daniel explore in terms of calligraphy, which is largely based on understanding how we move our own body? And the work you mentioned about sophisticated, not too invasive sort of 3D printing inside the body. Is it just a potential, or do you actually see something real there? And I was wondering about that because on the calligraphy side, we're getting an understanding of models of motion of human body. And I suppose in surgery, expert surgeons probably use something very similar to an expert calligrapher, sorry.
Yes, thanks a lot for the comment and question. I think absolutely, I fully agree. I think, you know, both executions are need a highly skilled professional, and you actually only are good at it if you're highly trained. And actually the challenges we face intraoperatively are super similar, right? We also, once we try to transfer the knowledge or the skillfulness of a surgeon to a robot, we have exactly the same challenges as were just described. It's so hard to teach a machine like to be aware of the surroundings and to get the feedback back from all the surroundings, and you need so many sensors, and then you still need to tweak them and you know, interpret the feedback properly. And also you need to account for stuff that can go wrong. And you know, in surgery, like one of the nightmares is of course that the surgical robots makes very uncontrolled rapid movements, which basically is, you know, pretty deadly for the patient. And I think there are a lot of like parallels, mostly on skillfulness and how to transfer human skillfulness to a robot.
A last question. I have a bit provocative one, maybe. What do we have here?
Yes, thank you. Yes, I think from the beginning, I'm sort of part of team, so therefore I knew a little bit about, you know, these things going on with developing this project, Liat and Danielle. It's interesting, you know, this lady asking about, you know, worried about, you know, something like if we start using new technology, we're losing our knowledge, you know, sometimes something like a craftsmanship, like a bodily embodied knowledge, tacit knowledge. So, but just thinking, something like closing a door makes open the new door. What I'm saying is, I just want to ask you both, you know, when you all start using new technologies, suddenly you have to develop your new type of way of working with machine, with people. So therefore, this kind of, you develop a new type of craftsmanship, or new type of way of working. So this is a sort of open up sort of kind of a future, you know, a new type of artist. Well, I'm not necessarily new, but with art. What do you think? In just curiosity for both.
Yes, no. I think I have fun working. I will respond for me personally, and the art might be different. I enjoy working with machines. I enjoy, on the side, the technological challenges, what they enable, the precision, the challenge with the precision, and so I don't know. It's of course a new way of working, but at the end of the day, yes, it's a tool which I enjoy working with. Yeah, I don't have much more to say about that.
Yeah, I have to agree with like with Dan. There is, I think, something that give you the opportunity to define a new aesthetics, because it's a new field. But I think this is something that we see along art history. When there was a new change, I don't know, different kind of paint came out into the market, a new kind of painting style came out following that. And this is a new kind of a tool that is not being designed for the art, it was being designed for the industry, but it is something that affects our creation and our ability and our way of thinking as society, and I see no reason why not to try and define it as an artistic tool as well, and to I think, expand and enhance what we know so far, and not necessarily closing a door behind. It's more like opening another one, and I can like run freely in the corridor and like change doors when I want to. More like this.
Thank you. So I have a question. Since you are using a robot, very precise one, have you ever thought about playing with interleaving layers? You know, because I see that you draw one layer, then another layer, then another layer. And have you ever thought about using this as a 3D, a third dimension, you know, by having a layer going underneath another layer? The next layer is going underneath the previous one, you know what I mean?
Yeah, I think now it's mostly also a time, and it would be really interesting and a nice challenge. But here I think it's a practical, you know, well, I live in London, I can be here for a certain amount of days. so there is a practical consideration. How long is it going to take to finish it? Well, so it would be definitely interesting to explore ways of interleaving layers, though, definitely. And we explored a bit, but with very little control, I would say. The drying of the paint makes a big influence, right? So if you don't dry the paint and you start painting right away, you get a blend of colors, which is very hard to predict. But there is a threshold where you dry it just right. And then it mixes a bit, which is nice, but it's very hard to reproduce. Let's say one day we had it, next day it was raining, and the drying time changed completely. So there's even factors of the weather that come into play. Yeah.
Okay, maybe one question to the audience, because this is a science communication project which is funded by the Swiss National